This project is looking at measuring the cost and environmental impact of electronic waste take-back legislation. So there's a lot of motivation for recycling electronic waste. One example is landfill diversion, saving space in landfills, also keeping out hazardous materials from entering landfills and potentially having issues with leachate. Also avoiding electronics being shipped to developing nations where they may be processed without the safety measures that are necessary to protect the workers and to protect the environment. Reuse of electronics, which can delay purchase of new products and reduce the number of electronic devices entering our system. And lastly, recovering the material from electronics. There's a lot of metals, plastics have value and can offset or prevent the production of virgin materials. So that's some general information about why recycling electronic waste is of interest. But in the U.S., there are about 4 states that have take-back legislation where manufacturers essentially pay for recycling of end-of-life electronic devices. And what we're interested in is looking at these such states where they have those programs and estimating what the impacts are from people actually returning their waste, the logistics of shipping it, treating it, and seeing how that quantifies compared with other steps in the process, and also can that be reduced by optimizing the reverse logistics network. So for this project, we've built life cycle process models to represent the collection, disassembly, and processing and transportation for electronic waste. And for each of those steps, we predict the costs and emissions from processing a ton of electronic waste. And those values are input into our optimization model. So what we've done so far is, for our baseline scenario for our case study area, we've run our model to estimate what's the least cost solution and what's the least emission solution, and get an idea of how much it costs to reduce 1 ton of carbon dioxide for our system. And some preliminary findings that we have are that the consumer return of electronic waste is actually a pretty big contributor to emissions and costs if you count the fuel use by people that are returning their own waste. Now, that needs further scrutiny because we're assuming that every household returns something each year, which may or may not be the case. But nonetheless, it's still a large fraction of the emissions. So having more places to drop off electronic waste might be beneficial from the system perspective.